This is my mom and me. And actually, the picture didn't come out as well as I thought it might, but I was looking for a picture. My mom's now 95, and she's gorgeous. I mean, she's always been gorgeous. I've always looked up to her as just, I mean, she really has stayed active, healthy, um, mostly eating right, although she did go up through the 40s and 50s, and when people started eating, they like Jello. But I when I see this picture and I look closely at her, she's in her upper 50s. She's actually younger than the picture of me in that. And it just shows a little bit. She's already gotten some wrinkles, and she also already had degenerative diseases. So she got arthritis when she was in her 30s in her hands pretty badly. And it was tough because she was also a pianist and a musician. And she just had to work through it. And she said, the more she played, she said, I just worked through it. But her entire adult life, she has been dealing with a lot of arthritis and some other things too, a little bit of cardiovascular disease later. But, it's just interesting to know, what does cell signaling have to do with aging healthy? And I must admit, I actually, in my early 40s, I started getting arthritis also, and in my hands in particular. And interestingly enough, I changed my lifestyle some, and I changed some nutrients I was taking, and I have zero sign of arthritis now at over 60 years old. So I like that. Now, one of the things we think about when we're aging, often what happens is you go to the doctor and we begin to be more susceptible for degenerative diseases. I mean, it's just sort of a fact of life with, as the doctors will say, well, you're just getting older and this might happen. You don't want to have cancer, but they'll say if you get arthritis, that was my phone. If you get arthritis, they'll say, well, that's just part of getting older. Or sadly, neurodegenerative diseases, you start having some trouble with your memory. That people will say that happens. Sexual dysfunction, cardiovascular diseases, that's just so common these days. Most of these symptoms, it says degenerative diseases in here, but I've seen the exact same chart that said inflammation in here. And so a lot of it, what we've thought about it, is just a lifelong chronic inflammation causing some of these diseases, as well as causing some complications in infectious diseases too. When you add on the chronic inflammation and the degenerative diseases and infectious diseases, it tends to make us more susceptible. So we, for years in the 50s, Denman Harmon talked about free radicals, and these are the oxygen, like they're a reactive oxygen molecule that actually does not have enough electrons, and so it goes around stealing electrons from our healthy cells. And he steals it, and then they get another one and another one. It goes into a little chain, and then you just have this poor little sad cell sitting there who's not feeling well. Now, we knew that antioxidants actually are happy to share electrons. They have a little extra, so they are very generous, and they do sort of tame down the free radicals if needed. So we knew this particular thing. But the problem is we haven't been seeing that in the research in the past 10, 15 years. We're getting, in the research, we're seeing that if we take large doses of antioxidants, it's not getting the results. It's not solving the issue of degenerative disease like we used to think. I mean, I even remember teaching, you need antioxidants and you need to take a lot of A, C, E, and beta carotene. You know, take these antioxidants and that's going to help you. Well, those are wonderful nutrients and we do want to be taking them, but they don't really work the way we thought they worked. It's sad. So it's, even though they're a very important part of our nutrition, and it is a good team to have antioxidants, we need to have something else too. We need to work further. So what have we got? We've got the mighty mitochondria. And I tell you what, the mitochondria, studies in the mitochondria have shown that what we knew about free radicals and antioxidants doesn't exactly work the way we thought they did. The mitochondria, most people got it in high school biology as the powerhouse of the cell. And they actually, they metabolize, they help the metabolism of glucose and the oxygen we breathe to form ATP energy. And that's one of the main things. When I was in school, that's all we kind of thought mitochondria did. And while they're making that energy, they're producing more free radicals. And the free radicals, of course, that's so we thought, okay, so we need the antioxidants for the free radicals because the free radicals do cause damage to our cells. But they've discovered that mitochondria do a whole lot more. They're much more essential. They regulate blood pressure, gene expression, cells do, has a big part in cell signaling, protein activation, cell turnover, cell recycling, and our body's immune response. So these are absolutely, the mitochondria and the free radicals are very important in all these processes. So we have learned, nature has learned to live with the free radicals, and they've learned to use them even to our advantage, which is pretty amazing. So being our cell's powerhouse is not the only role of mitochondria. Who would know? So they're quite mighty indeed. And we'll be talking a little bit more about mitochondria. I'm going to check quickly and see if anybody's waiting. Okay. Now, the redox theory of aging. This is one of the more recent theories of aging that is very interesting. Again, free radicals do have a part in it, but it's this like seesaw balance from the stable cell, the stable balance of free radicals and antioxidants. They want to be balanced because you want to kind of like when you were a kid on a teeter-totter. Did you ever do this? Did you ever get up on a teeter-totter and get in the vortex, right in the middle of it? And I did that a lot. Our playgrounds had lots of seesaws. Quite dangerous, but I did it anyway. So this is what happens. It's a balancing act, and it balances molecules balance from the oxidized reactive state to their reduced, more stable state. So you want to, what this proposal of the redox theory of aging is that our cells are going back and forth in those states. And of course we want them over here where they're healthy. And here's our little mitochondria there. And then, but when it's overcome by more free radicals, then we can balance. Then we start getting mitochondria that don't work well. We get other organelles that don't work well. We get chromosomal damage, that's the DNA damage. So this is what tends to happen as we age. It gets tipped about starting in our 40s, maybe a little earlier, where that shift in this redox state from the stable state to the more reactive state, it moves this set point, and we end up going off over here to the right, a little bit more damage. That accounts for a lot of high susceptibilities in immunity, and increased inflammation as we get older, increased chronic degenerative diseases. So antioxidants, I don't know if you know, But there's two different kinds of antioxidants. We all keep thinking of the kind we eat, and that we're just using, you know, the fruits and vegetables that we eat, that they're just fighting the free radicals directly. But they have to be absorbed, they have to be metabolized, and distributed to the site in order to be effective. And then those vitamins, those C and E that are antioxidants, they only work once. So that's the fascinating thing. It just takes so many more molecules to counteract free radicals in the exogenous antioxidants. So then there's endogenous antioxidants, and they're produced in our own cells, and their effect is hundreds of times more powerful than exogenous antioxidants. You could think of them as little machine molecules that are just churning out the electrons to quench the free radicals. They give your body a much better defense against oxidative stress. And really, if you want the ultimate defense, you want these. Some of them are enzymes. Some of them are molecules like glutathione. You might have heard of glutathione. That just goes back and forth very easily into the different states. So the glutathione can be refreshed and then go back and fight more free radicals. So why am I talking about these antioxidants, and why am I talking about redox signals? What does that have to do with cell signaling and healthy aging? Well, these are pathways making the endogenous antioxidants, and the pathways of balancing the redox are all run by cell signaling. This is a little cartoon. I don't know if you can read it, but it's kind of a bad joke, but I had a laugh on it. I'm going to read it for you. It said, Jay, can you hear me? And this man is like, he's sort of floating in space, I guess, or floating in cellular fluid. What's going on? I feel so lethargic, moving so slow. Why don't I have any energy? Well, you should try giving your mitochondria a call. They'll rev up your energy levels. Give what a call? Mitochondria in my body? I can do that? What do you think your cell phone is for? Then he wakes up, he says, I got to lay off the buffalo chicken pizza before bed. And I laughed at that because that buffalo chicken pizza was actually cell signaling his body to not have energy, which is kind of interesting. And when we support our mitochondria, that's when we're going to be gaining lots more energy. So how do we support our mitochondria? Well, there's something called, let me say it right, autophagy and mitophagy. And autophagy means eat self, which is kind of gross. But it is really true. It's what happens and mitophagy is specifically cell turnover for the mitochondria. Okay, so it's turning over specifically the mitochondria, but all our cells go through autophagy. That's how we have cell turnover and have new cells. Our skin cells go through that, and that's why, and then it rises up, and then we get fresh new skin cells. That's why we want to do, some skincare that feeds this, that actually signals this. But anyway, how this works is it's kind of like a cleaning process. It takes those old damaged cells and cell pieces, and it first puts them in this little phagophore. It's just a little lining, a phagosome. And then this lysosome comes around. It's triggered by cell signaling to come, and it's filled with enzymes. It merges, and it sends the enzymes out that breaks up all the cell organelles, what it needs, all the way back to the amino acids. So then we have the fresh building blocks for all our cells. That's how that's why one of the reasons why nutrition is so important in healthy aging is because it takes certain nutrients actually do cell signaling to start this process. And they actually do it the right way. And then when you're building the cell, there's other nutrients you need in order to build it back right. So I'm going to look at these nutrients. Here we go. That support cell signaling. And there's an awful lot of them. I'm going to focus mostly on polyphenols because these are things that a lot of wonderful plant nutrients that, when we want to eat the rainbow. Omega-3 fatty acids are really important in cell signaling. I had another talk about immunity because it damps down inflammation. It helps that pathway to damp down inflammation. But today I'm going to talk more about the polyphenols. These are phytonutrients that are produced in plants that have formed defenses to common environmental stress. So the plants themselves have developed a defense to drought, to intense sunlight, to insects, to molds, fungi. They've developed these biologically active compounds, and they show up sometimes in colors of the plant, in the berry, or the green of the leaf. They're just fascinating, and sometimes even in the roots of the plants. So the biologically active compounds do not only benefit the plants, but anything that eats them. So we eat plants, we're incorporating a lot of these nutrients that actually then go out and do the cell signaling that helps support us. So polyphenols are often concentrated in the plant's leaves, and they deter predators and they keep the plants healthy. And they're also the largest class of antioxidants in your diet. And they regulate signaling pathways, in particular of the autophagy and the mitophagy. So this is how they support healthy aging. These are some of the polyphenols that you may have heard of, you may be familiar with. Resveratrol, I know I've heard of that for a long time, and people talk about in the French drinking the wine, they were thinking that it was resveratrol that helped them. And I think that might be a little piece of it, but not all, that helped them stay thin and lovely for a longer period than some of the rest of us. But grape skins and berries and red wine. But one of the interesting things about resveratrol is other studies have shown that calorie restriction turns on specific pathways. That pathway is called NRF2, and it's become a very popular pathway to talk about because NRF2 turns on, back up here, it turns on the endogenous antioxidants. So these antioxidants that are in our body and often inside our cells. So that's what resveratrol does. And it has they've got lots of studies on preventative effects, and they're saying that it has some really good preventative for some cancers and some heart disease. EGCG, I know a lot of people have heard of that in green tea. It sort of became a fad to drink everything green tea. It's very critical in this autophagy and monitoring cell death. So it's very important, and it also, they've seen it actually help that autophagy, killing off the cells of cancer cells too. The psilocybin, you may not have heard the psilocybin name, but I bet you've heard milk thistle. And milk thistle is very commonly used to help liver support. And it helps with cell signaling to help that phase 2 detox. So that's why you take milk thistle for that. And quercetin is a very large group of polyphenols and flavonoids. It's the most abundant of flavonoids class, and it downregulates something called mTOR, which is yet another pathway. I learned in my research of, just reading the research of all this, there are thousands and thousands of pathways, and there's only a few that people talk about, but these are some. And the mTOR is responsible for protein synthesis, cell growth, nuclear transcription, and like all these others, autophagy. So all these different, this is why you want to eat these foods. Makes sense. And it also activates a protein that influences cell survival under stress. So when we're stressed out, our body is signaling us that, oh my gosh, they're stressed out. And it actually causes some problems in our cells. But if we're also eating some of these berries, apples, if we're also having a very good diet, we're going to be able to get through stressful situations a lot easier. And then I know people have heard of curcumin and turmeric root, very good anti-inflammatory, but it also modifies several genes that are related to longevity. And that's something that I didn't know till I did this research. It's pretty amazing. But it's not that, it's also anti-inflammatory, antibacterial, antiviral, antifungal, antispasmodic. So it's definitely a good thing to have in your diet. Then we do. So all those actually take care of our mitochondria too, because we want to have that mighty mitochondria. Because what happens when mighty mitochondria is not mighty? It's very sad, but it says, not only the first thing you notice is that you're, just don't have a lot of energy. You're losing energy. You're feeling tired. The second thing you notice is that you may develop more of those degenerative diseases because older mitochondria that are not doing that well actually become less efficient, and they knock out a lot more free radicals than they do when they're fresh and younger. So we want to have this mitophagy of the mitochondria to keep getting the fresh new ones. They've actually done some specific research. When people do not have sufficient active mitochondria, they said that it can be a main culprit in some cancers, but a lot of the neurodegenerative diseases, Alzheimer's, Parkinson's, and then the ones that almost so many people have, cardiovascular disease and type 2 diabetes. I mean, that's just, so many people have those. So I had not put that connection together about mitochondria and Parkinson's and mitochondria and Alzheimer's. Now, there's other nutrients also that support healthy aging. These are important, especially also for mitochondrial health, and protects neurons and prevents cell damage. Vitamin D3 is super important in the immune system, and it actually is a direct cell signaling. It acts as a receptor for specific cell signaling that turns on our adaptive immune systems. So it really crosstalks back and forth with that. And the N-acetylcysteine is a redox signaling agent. So it really helps that teeter-totter. It helps bring it back to the positive, to the healthy and unreactive side. And it actually, N-acetylcysteine helps when we have stressors from outside or within our body, but stressors like environmental stress or emotional stress. And that's another thing I learned in my research. And N-acetylcysteine, my mouth is not working well, is good for that. So this is a quote that I love, and there's going to be, I know a couple of people might know this quote, but it is so relevant. We live too short and die too long. We're living longer in poor health than ever before. Our quality of life is increasing while our quantity of life is increasing, while our quality of life is decreasing in spite of our ever-rising standard of living. We are overfed and undernourished. And this is Dr. Myron Wentz, who actually was the founder of quite a few things. He founded USANA, he founded the Sana Vive Medical Institute, and he founded quite a few medical hospitals, holistic hospitals for women and children across the world. And thank you very much. Here's my contact information. And I wanted to give you a quick note. All these nutrients, please don't go to your local health food store and buy them, because what works for cell signaling, you don't need the nutrients in large amounts. Don't go back to taking massive doses of antioxidants in order to try to solve degenerative diseases. It takes some of these in small amounts, and the ratios are extremely important because they work together. So if you want to know a little bit more about that, please contact me.